Welcome to another video in the ESG series. Today we'll be diving into the carbon footprint calculation process with a focus on Scope 1 and Scope 2 emissions. Understanding these emissions is crucial for any organization aiming to tackle climate change and improve efficiency. Let's explore how we can measure, manage, and reduce our environmental impact effectively. Carbon footprint is the total greenhouse gas emissions caused by an entity, either directly or indirectly. It's all about measuring and managing these emissions to combat climate change, boost efficiency, and align with global standards like the Paris Agreement. We'll look at the main greenhouse gases, carbon dioxide, methane, and nitrous oxide, and how they impact our planet. Greenhouse gas emissions are gases that trap heat in the Earth's atmosphere, contributing to global warming and climate change. The key players here are carbon dioxide, mostly from burning fossil fuels and deforestation, methane from landfills and agriculture, nitrous oxide from fertilizers and fluorinated gases, typically from refrigerants and solvents. Understanding these sources is vital for effective carbon management. Greenhouse gas emissions disrupt Earth's natural greenhouse effect, leading to rising temperatures, melting ice caps, and severe weather patterns. Industries play a major role in this. Our focus is on how excessive emissions lead to heat trapping, resulting in global warming and subsequent climate change effects. Understanding this cycle helps us tackle climate-related challenges more effectively. Greenhouse gas emissions have a profound impact on our climate. They lead to heat trapping, causing temperature rise and global warming. As a result, we see more extreme weather patterns and climate disruption, affecting biodiversity and leading to habitat loss and species extinction. Understanding this chain of effects underscores the urgency to manage emissions. Industries contribute significantly to greenhouse gas emissions through various processes, from industrial activities that boost emissions to inefficient practices that increase waste. The impact is substantial. Product use adds to the carbon footprint, and without effective mitigation efforts, progress towards sustainability is hindered. Addressing these areas is crucial for reducing emissions. Why should a company care about its carbon footprint? It's simple. Reducing emissions enhances employee engagement, builds trust with stakeholders, and strengthens reputation. Moreover, it boosts competitive differentiation, ensures compliance with regulations, and attracts investors. Ultimately, it's about saving on operational costs and mitigating risks, ensuring the company remains resilient in the long run. Here's how we calculate greenhouse gas emissions step by step. First, identify the emission scopes and sources. Then, collect the relevant activity data. Select and apply the right emission factors. Convert the units and aggregate the results. Finally, verify, document, and report your findings. Following these steps enables precise measurement, guiding effective emission reduction strategies. Greenhouse gas emissions are categorized into three main scopes. Scope 1 covers direct emissions from sources that a company owns or controls. Scope 2 focuses on indirect emissions from the energy a company purchases. Scope 3 includes other indirect emissions from activities like transportation and supply chain. Understanding these scopes is vital for comprehensive emissions management. Let's break down the sources of emissions. Scope 1 includes on-site fuel combustion, company vehicles, chemical processes, and refrigerant leaks. Scope 2 focuses on electricity, heating, cooling, and steam that a company purchases. Scope 3 encompasses upstream and downstream activities, employee commuting, waste disposal, and product use. Knowing these sources helps in targeting and reducing emissions effectively. Diving into Scope 1 emission sources. These are direct emissions from owned or controlled assets. We have mobile combustion, like emissions from cars, trucks, and delivery vans. Then there's stationary combustion, from boilers and furnaces. Fugitive emissions come from things like air conditioning units and refrigerators, while process emissions originate from industrial machinery and chemical processes. Understanding each of these helps in effective emission management. Scope 2 emission sources relate to indirect emissions from purchased energy. This includes purchased electricity from power plants, heating and cooling from central systems in buildings, and steam used in industrial processes. These are critical for assessing indirect impact, highlighting the importance of selecting sustainable energy options. In managing Scope 1 emissions, start by identifying the direct sources. For fuel consumption, note the type of fuel, when and how much is used. With mobile combustion, track the type of fuel, distance traveled, and amount consumed. Fugitive emissions require monitoring refrigerant use and any leakages. Lastly, process emissions need you to identify key processes, types of chemicals, and quantities used. This detailed tracking is essential for accurate measurement and reduction. To capture and collect Scope 1 emission data accurately, begin with fuel consumption. Capture fuel types and amounts using purchase records and meters. For mobile combustion, track fuel type, distance, and consumption using logs and GPS. Fugitive emissions require monitoring refrigerant use and inspecting systems regularly. Process emissions involve identifying key processes and estimating emissions with appropriate factors. Consistent data collection is key for effective emission management. Let's identify the indirect emissions in Scope 2. Purchased electricity involves tracking energy consumption from various sources, impacting overall emissions. Purchased heating and cooling refers to the energy used for temperature control, which affects emissions indirectly. Lastly, purchased steam, often used in industrial processes, also contributes to indirect emissions. Understanding these sources allows for better energy management and reduction strategies. Capturing Scope 2 emission data requires precision. For purchased electricity, obtain utility bills, use submeters, and track green energy credits. For heating and cooling, check utility bills and install energy meters for accuracy. When it comes to purchased steam, obtain steam data and use installed meters. These steps ensure thorough and reliable data collection for better emission management. To determine emission factors, there are three key sources. Energy providers' reports offer factors based on your local energy mix. The Intergovernmental Panel on Climate Change guidelines provide global factors for various fuels and energy sources. The U.S. Environmental Protection Agency databases offer factors specific to local fuel and energy sources. These resources ensure accurate emission calculations tailored to your needs. Here are some examples of emission factors. For Scope 1 fuels, we have diesel at 2.68 kilograms of CO2 per liter and natural gas at 1.89 kilograms of CO2 per cubic meter. Moving to Scope 2, electricity from the US grid is 0.453 kilograms of CO2 per kilowatt hour. For steam, natural gas heating is 1.92 kilograms of CO2 per cubic meter. These factors are crucial for accurate emissions calculations. Calculating your carbon footprint involves a simple formula. Multiply your activity data by the emission factor to get the emissions. Then apply the global warming potential to convert these emissions into total emissions in tons of CO2 equivalent. Activity data is about tracking what actions contribute to emissions, while the emission factor measures how these actions convert to emissions. Finally, the global warming potential helps compare the impact of different greenhouse gases, turning it all into the universal language of CO2 equivalent. When calculating emissions, unit conversion is vital for consistency. For fuel consumption, know that 1 liter equals 0.264 gallons, and 1 gallon is 3.785 liters. For electricity, 1 kilowatt hour equals 3,412 British thermal units. When dealing with distances, 1 mile is 1.609 kilometers, and for weight, 1 metric ton is 1,000 kilograms. Remember, the global warming potential of methane is 25 times that of carbon dioxide, which helps in converting emissions to CO2 equivalents. Conversions ensure accuracy across all metrics in your calculations. Let's walk through some example calculations. For Scope 1, consider fuel consumption. With 500 liters of diesel and an emission factor of 2.68 kilograms of CO2 per liter, you'll get a total of 1,340 kilograms of CO2 equivalent. For Scope 2, with electricity, if you use 10,000 kilowatt hours and the emission factor is 0.453 kilograms of CO2 per kilowatt hour, you end up with 4,530 kilograms of CO2 equivalent. Finally, purchased heating. With 3,000 kilowatt hours and an emission factor of 1.92 kilograms of CO2 per kilowatt hour, your total is 5,560 kilograms of CO2 equivalent. These calculations show how to quantify your emissions accurately. Aggregating emissions involves several steps. Start by calculating emissions for each source to get detailed insights. For Scope 1, add up emissions from direct sources like fuel and processes. Moving to Scope 2, sum up emissions from all purchased energy. If relevant, aggregate Scope 3 emissions from the wider value chain. This gives you a comprehensive picture across all scopes. Here we see Scope 1 at 1,500 tons and Scope 2 at 2,000 tons of CO2 equivalent. This aggregation helps in setting informed and effective reduction targets. Verification and documentation are crucial in emission calculations. Start by cross-checking your data. Review activity data, confirm accuracy, and recheck emission factors to ensure reliability. Document every step, including data sources, any uncertainties, and make sure this documentation is easily accessible. Verification means aligning with standards and double-checking assumptions. This process builds trust and transparency in your emissions reporting. When reporting findings, focus on key insights by highlighting major sources and addressing data challenges. Ensure a clear scope breakdown to separate emissions for transparency. Use data visualization. Charts and graphs can effectively communicate your results. Remember to compare the current data with previous periods to track progress and identify trends. This comprehensive approach makes your report both insightful and actionable. Using results for goal setting is all about creating an effective emission reduction strategy. First, set targets. Define short-term, medium-term, and long-term goals within a specific framework, like the Science-Based Targets Initiative. Develop strategies by focusing on energy efficiency, expanding renewable energy sources, and improving fuel efficiency. To track progress, engage in regular monitoring, keep your reporting systems up to date, and stay on top of emerging technologies. Analyze sources by reviewing aggregated data, pinpointing the largest emitters, and concentrating on high emission areas. This systematic approach helps drive meaningful change and achieve your sustainability goals. This slide illustrates an example of goal setting for emission reduction. It starts with initiatives to reduce energy consumption, such as transitioning to renewable energy and implementing energy-saving measures. Installing efficient production equipment and management systems is key, alongside upgrading to LED lighting and optimizing HVAC systems. The timeline sets concrete milestones. Initiate a 15% reduction in Scope 2 emissions by 2023 and achieve a 20% reduction in both Scope 1 and 2 emissions by 2026. Negotiating with energy providers and purchasing renewable energy certificates contribute to reaching these goals. By strategically planning and implementing these initiatives, you can significantly lower emissions and drive sustainable progress. Thank you for your engagement today, and if you're ready to embark on your own environmental, social, and governance journey, don't hesitate to contact us at esg@lemonconsultech.com. We're here to guide you every step of the way.